Hi class, welcome. Today we're gonna go over multiplying polynomials, and we're gonna do a quick check on some of the terminologies that we use in math. So just keep that in mind, and I'll try to use these terms along the way. But it's important for us to know these terms because that will introduce the language that we need in the future. So we'll start with what does it mean to be a polynomial? A polynomial is an algebraic expression such that the exponent on the variable is a positive positive integer. That means that it could be any number that you use to count, like 1, 2, 3, 4, 5. You can have also what we call the zero polynomial, like the zero power, right? And we know that x to the 0 or anything to the 0 power is 1. Of course, except 0 to the 0. So that would be this case right here. So a polynomial has a power of that is a whole number. And so what would be not a polynomial if you had a power that had a -1? That's not a polynomial. If you had a power that was 1/2, right, then the whole thing is not a polynomial. So they have to be counting um, numbers that we use for counting, right? So now it's an algebraic expression. So here, this is a polynomial. This is a polynomial as well, because again, the power of the exponent is a whole number, a positive whole number. So now this polynomial right here that we have right there, that has 3 terms. If you notice, this is one term, and then if you notice there's a minus, so that separates the other term, and then there's a plus right here, so that separates the other term. So we have 1, 2, 3 terms. So if you count the terms, then that tells you how many what kind of polynomial this will be. This is called a trinomial, right? Tri comes from the word 3, so it's a polynomial that has 3 terms. Polynomial means that is many, right? So many nomials, right? This instead here is what we call one term polynomial, right? If you have this by itself, then this is called a monomial. The word mono comes from the word one. It's important for us to know, but we'll keep talking about these as we go through. Now, this whole thing as a whole, right? Then we know that this will be at the end a trinomial. All right, so let's begin. So this is a product of 2 polynomials, right? 2 polynomials. So this polynomial multiplied by this polynomial. How do we know it's a multiplication? Because in math we actually have a hidden dot in here. When you have a parenthesis, it is determined that we are doing a multiplication. So we have a multiplication of this term with all these 3 terms. So how are we going to multiply this? So what I like to do, and I have been doing this since the first time I learned. It makes sense to me. I'm a visual person, so what you need to do, you need to do distribution. So we have to do a distribution, right? This is a rule in mathematics that tells you that we need to distribute every number, every factor into every term, right? So that's what we're doing. This is called distribution, right? So here we have let's talk about another term here, another terminology. This right here is being multiplied by this. Whenever you're multiplying, we have a special name for that. So we have let's say a times b, right? So when you're multiplying, the end result is going to be a product. Let me give you an example. 3 times 7, and this will give you 21, right? In mathematics, this is known as a factor. It's the item that you are multiplying, right? So whenever you're multiplying 2 items, then these are factors. and then the end result is called the product, right? The end result is the product. So here it doesn't matter whether you you have an algebraic expression, right, or just simply two numbers. It's still the same process, right? You have to think about this as being a single number, right? It's a number. It's a number. So this is being multiplied to this number. So nonetheless, this is called a factor, and this is also another factor, right? So these are two factors, right? All right, so let's go ahead and do the distribution as we promised. So let's go ahead and do this, right? We're gonna multiply that factor, right, or with that term. We're gonna multiply that factor with that term. We need to do the distribution, right? The distribution is because we have this parentheses, and this factor needs to be distributed to everyone in there. So let's go ahead and do that. Of course, I'm gonna do, since we're sort of reviewing here, excuse me, we're gonna go ahead and do extra steps. So we're gonna begin with the first one, 5x to the 4 times 2x to the second, followed by the 5x to the 4 multiplied by minus 3x. So we can utilize this minus here. So we're gonna put the minus here, and we're gonna multiply 5x to the 4 and then multiply it by the 3x. Right, so think about that minus, it's right there. And then 5x plus 4 times this plus 1. So this plus 1 can be, we can think about it as being there. And then, and you also have to remember that there's technically like a positive 5 there. This does not have a sign, so whenever it does not have a sign, we assume it's we know it's a positive. So we're gonna have plus 5x to the 4 times the 1, right? So we still got to multiply it to the 1. So if you notice here, what we're going to do here is we're going to multiply these terms. So now if we think about it, remember what we said, that when you multiply these two, the end result was going to be a trinomial, and we kind of see that this is one term, this is going to be another term, and then this is going to be another term once we complete this product. So let's begin with the next one. So when you multiply these two, we have to keep in mind that what we're going to do is multiply the number with the number and the x with the x, right? So let's go ahead and do that real quick. 5 times 2 is 10, so that's not so bad. Now we're going to multiply x to the 4 times x squared. So x to the 4, and I want to remind you that we have a rule for that. When you multiply variables, they need to be the same base to be able to have a product, and so what we're gonna have here is what's going to happen when you multiply these two, you add the powers. So this is gonna look like this. So x to the 4 plus 2 gives you x to the 6. And let me give you an example. If we have the same thing, right? 3 to the 4 times 3 to the second. What would happen here is we will multiply, because they have the same base, we can multiply them, and so this will give us 3 to the 4 plus 2, right? So the exponents will equal each other. I mean, so we add each other, and then we get x to the 6. And then and that's pretty much it. So one way you can think about it is that you have, 3 times 3 times 3 times 3, right? That's the same. The definition of multiplying 3 to the 4th. The definition of having 3 to the second is multiply 3 times 3. So just like that, you're multiplying the 3, 1, 2, 3, 4, 5, 6. So this is equivalent to 3 to the 6, right? So we end up getting the same result. And I made a little mistake here. That was intended to be a 3 to the 6. So sorry about that. Let me correct that. There you go. All right. So that's how we can think about it. So this is the general rule right here, right? What we do is we add the powers when you're multiplying the variables. So that's what we have. X to the 4 here times x squared will give us x to the 6, followed by the minus, and then multiply the 5 and the 3, so that will give us 15, and multiply the x to the 4th with the x. We'll do that over here. X to the 4 times x. There's an imaginary 1 always in there. There's always a power. So if there's no power written, then we assume that that's a power of 1, right? We know it's a power of 1. So we'll do the same thing. We have the same variable, so that will be 4 plus 1. It'll be, sorry, I keep thinking ahead. My mind is like that. It's always thinking 2 steps ahead, so I always have to slow down my mind. 4 plus 1 is 5. All right, so that means that we have here x to the 5th, and then plus, and then now we multiply 5 and 1, so that gives us 5. And then we don't have anything here. If you want to think about it, we could think about like, oh, this is gonna be the x to the 0, right? X to the 0. So whenever you have a constant, you technically can say there's always x to the 0, right? So it will be x to the 4 times x to the 0. Well, what happens there when we said that when you have multiplying the variables, you add their exponents. So 4 plus 0 is x to the 4, right? So we don't have to do that again, right? As long we can just sort of maybe carry it over at the end, right? Because we don't need to have the x to the 0 there. All right, so that's it. So let me simplify this. We started with the problem asking us to multiply these two polynomials, and the end result was 10x to the 6th minus 15x to the 5th plus 5x to the 4. Right, so that was the answer, and that. So that's it. We'll start with another video for polynomials. So see you next time.